Hello students, good morning. So we are discussing about planes, and we have seen different form of equation of planes and the different conditions given. Okay. So in this session we will be studying about coplanarity of two lines or condition for coplanarity of two lines. So this derivation will be important again. For 5 marks type question, derivation will be given. Okay. So what will be the condition so that two lines are coplanar? Coplanarity of two lines means condition so that two lines are coplanar. What are coplanar means? Lines lying in the same plane. Okay. Lines lying in same plane are called as coplanarity of two lines. So we will derive the condition here. So first let us take two lines. So again here we will derive the condition both in vector as well as Cartesian form. Let us take two lines. Let L1 r bar equal to a1 bar plus lambda b1 bar and L2 r bar equal to a2 bar plus mu b2 bar be two coplanar lines. Be two coplanar lines means they are lying in the same plane. Now this board is in the form of plane. So assume that the two lines are lying in this plane of the board. Okay. So we are taking two lines. Suppose this is the first line L1 and this is the second line L2. So what is the meaning of first line r bar equal to a1 bar plus lambda b1 bar? It is passing through the point with position vector a1 bar and parallel to the vector b1 bar. Okay. So first line is passing through the point, suppose A with position vector a1 bar, and second line is passing through the point suppose B with position vector a2 bar. And first line is parallel to the vector b1 bar. So direction of b1 bar is like this, and second line is parallel to the vector b2 bar. So this is the direction of b2 bar we can take. So this is the meaning of the terms present in the line equations. Now these two lines are coplanar. Okay, we are assuming that they are lying in this plane of the board. So when these two lines are lying in the plane of the board, where this vector b1 bar and b2 bar, they are also lying in this same plane. Okay, b1 bar, b2 bar lies in this plane of the board, and where the points a, b are lying, they are also lying on the plane of the board. Okay, so if by joining this a, b, we get vector a, b bar like this. A, b bar is a vector. Now when the points A and B are lying on this plane, what about vector AB bar? Now this also lies in this same plane. So from diagram B1 bar, B2 bar and AB bar, all these three vectors are lying in this same plane. Okay. Now what condition we can take here? Say I will take B1 bar and B2 bar. Now for these two vectors I will take cross product. Okay. B1 bar and B2 bar. For these two vectors I will take cross product. So it is B1 cross B2, B1 bar cross B2 bar. It is vector which is perpendicular to both B1 bar and B2 bar. So this is the direction of B1 cross B2. Okay, you have to imagine B1 cross B2 is perpendicular to both the vectors B1 bar and B2 bar. So it is perpendicular to the plane of this board. Okay. Now as AB bar lies in the plane of the board and B1 cross B2 is perpendicular to the plane of the board. So what will be the angle between AB bar and B1 cross B2? They are perpendicular. So AB bar is perpendicular to B1 cross B2. Two vectors are perpendicular means their dot product is 0. So using that condition we will derive the condition for coplanarity of two lines. Understand? So if you want, you can write a theory here. the vectors b1 bar and b2 bar are lying in the same plane. Okay, when two lines are lying in the same plane, b1 bar b2 bar also lies in the same plane, and the vector ab bar, okay, lies in the same plane where the lines are lying. Understanding? So first we are taking b1 bar b2 bar, then we are taking vector ab bar. So here what is the direction of b1 cross b2? Perpendicular to both the vectors. Here b1 bar cross b2 bar is a vector perpendicular to both b1 bar and b2 bar. Perpendicular to both b1 and b2 means it is perpendicular to this plane of the board. So from diagram, what we observe that vector AB bar which lies in the plane is perpendicular to B1 bar cross B2 bar. This is a condition we are going to use. AB bar is perpendicular to B1 cross B2, implies AB bar dot B1 bar cross B2 bar should be 0. These two vectors are perpendicular, so their dot product should be 0. What is AB bar? We can write OB bar minus OA bar dot B1 cross B2 is equal to 0. OB bar is position vector of second point, A2 bar minus A1 bar dot B1 bar cross B2 bar is equal to 0. This is a condition for coplanarity of two lines. Okay, two lines are lying in the same plane only when this condition is satisfied. A2 minus A1 dot B1 cross B2 is equal to 0. Okay, this is a vector form of condition. Now using vector form, we can derive the condition in terms of Cartesian form also. Okay, note down this vector form first. In Cartesian form, so what is A? It is a position vector of point through which first line is passing. I will take that point as x1, y1, z1. Let A is x1, y1, z1, implies OA bar is equal to A1 bar is equal to x1i plus y1j plus z1k. B is the point through which second line is passing. I will take it as x2, y2, z2. This is known points. Implies OB bar is A2 bar, x2i plus y2j plus z2k. Next, B1 bar and B2 bar. What is B1 bar? Parallel vector to first line. Now parallel vector to first line we can write in terms of DRs. Let B1 bar is A1i plus B1j plus C1k, and B2 bar is A2i plus B2j plus C2k. Okay, so these are the points and parallel vectors we are considering. So we are using the vector form to derive the Cartesian form. So first we are writing all the notations. What is A2 bar, A1 bar, B1 bar and B2 bar. Okay. So we need A2 minus A1. See what is A2 bar minus A1 bar difference? X2 minus X1 into I plus Y2 minus Y1 into J plus Z2 minus Z1 into K. So this is A2 minus A1 and we know B1 cross B2. Okay. So from vector form, A2 bar minus A1 bar dot B1 cross B2 is equal to 0. Now how can we write this? A2 minus A1, it is X2 minus X1 into I plus Y2 minus Y1 into J plus Z2 minus Z1 into K. This is one vector dot B1 cross B2. B1 bar is A1I plus B1J plus C1K cross product with A2I plus B2J plus C2K. Now how to take this product? Observe, it is in the form A bar dot B cross C. It is what? Scalar triple product. Okay, it is in the form A bar dot B cross C. So we have discussed the formula to evaluate this scalar triple product. A bar dot B cross C, it is written as determinant of components of first vector, then components of second vector, then components of the third vector. Okay. So this triple product can be evaluated by using determinant. Okay. So we will take the determinant of components of first vector. What is the first vector here? A2 minus A1. Components are X2 minus X1, Y2 minus Y1, Z2 minus Z1. Next, components of second vector. Second vector is B1 bar. Components are A1, B1, C1. And components of third vector, it is A2, B2, C2. So most of the students, they will stop here only. But is it correct? You have to write it is equal to 0. Okay. Here the condition is it must be equal to 0. This is B1 cross B2, B1 cross B2 is equal to what we have? 0. Okay. So this is a scalar triple product, you have to equate it to 0. So by solving this, or if this determinant value is 0, then only we can say that the two lines are coplanar. Understand? This is a condition in terms of Cartesian product. In terms of vectors, vector form, what is the condition? A2 minus A1 dot B1 cross B2 is equal to 0, then we can say that lines are coplanar. So if it is not equal to 0, then the lines are not coplanar, they are not lying in the same plane. Okay. So derivation will be important. Next, angle between two planes. Angle between two planes. So in the case of lines, we discussed how to take angle between two lines. How do we take the angle between two lines? L1 and L2. We know L1 is parallel to B1 bar and L2 is parallel to B2 bar. So angle between the two lines is same as angle between their parallel vectors B1 bar and B2 bar. Using that concept, we are finding the angle between two lines. Now here we need angle between two planes. Angle between two planes is same as angle between their normal vectors. Okay. Here the concept is angle between two lines, angle between two planes is same as the angle between their normal vectors. Okay. So this is a concept we are going to use to find the angle between two planes, which will be same as the angle between their normal vectors. Let us see diagrammatically here. So these are the two planes we are considering. This is the first plane and this is a second plane. Now the angle between these two planes we have to imagine. Okay. Suppose this is the first plane, this is the second plane. Now where they are intersecting, in between that we are finding the angle between two planes. So that angle between two planes will be same as angle between their normal vectors. See, for first plane, this is the normal vector, normal to first plane, this is n1 bar. Next, this is second plane, normal vector here, n2 bar. Okay. So this is n1 bar and this is n2 bar. The angle between these planes is same as angle between these normal vectors. So n1 bar, n2 bar we know, we can take the angle between them as same as angle between the required planes. Okay. So first we write in Cartesian, in vector form, then we write in Cartesian form. Vector form, let two planes we are taking. Let us take the planes r bar dot n1 bar is equal to d1 and r bar dot n2 bar is equal to d2. B2 planes. We are not taking in a normal form. This is general form we are taking. R bar dot n1 bar equal to d1 and r bar dot n2 bar equal to d2. B2 planes and let theta be the angle between the two planes. So again, it angle between two planes is same as angle between the normal vectors. What are normal vectors here? n1 bar is normal to first plane and n2 bar is normal to second plane. So angle between two planes is given by cos theta, because angle between two vectors we can find using cos theta, that is a dot product. So how can I write cos theta here? n1 bar dot n2 bar divided by magnitude of n1 into magnitude of n2. Okay. Using this formula we can find the angle between two planes. Okay, like this. This is the first plane, second plane, this theta we need. Now that theta will be same as angle between the normals. So for first plane you take normal and for second plane you take normal like this. So this theta and this theta will be the same only. Understand? This is in vector form. Now in Cartesian form, see how can you write angle between the two planes? We will take plane equations also in Cartesian form. let a1x plus b1y plus c1z is equal to d1 and a2x plus b2y plus c2z is equal to d2 be two planes. Now what are n1 bar, n2 bar in Cartesian product? n1 bar is a normal vector to first plane with the drs. What are drs of normal to this first plane? a1, b1, c1 are the drs of normal to first plane, and a2, b2, c2 are the drs of normal to second plane. So here a1, b1, c1 are drs. I'll take a2, b2, c2 also. a1, b1, c1 comma a2, b2, c2 are the drs of normal to first and second planes. Okay. a1, b1, c1 are the drs of normal to first plane, a2, b2, c2 are the drs of normal to second plane. So we can write what is n1 bar. Drs of normal binomial means we can write n1 bar as a1i plus b1j plus c1k, and n2 bar is a2i plus b2j plus c2k. So by vector form, what is cos theta we are written n1 bar dot n2 bar divided by magnitude of n1 into magnitude of n2. So therefore what is cos theta in Cartesian form we can write n1 dot n2, what is the dot product? a1 a2 plus b1 b2 plus c1 c2 divided by magnitude of n1 is root of a1 square plus b1 square plus c1 square into root of n2 bar magnitude is a2 square plus b2 square plus c2 square. So this is the formula in terms of Cartesian product, how to find the angle between two planes. Okay. So notation we have to understand here. What are a1, b1, c1 drs of normal to first plane, a2, b2, c2 drs of normal to second plane. If you observe and if you remember, the same formula we are using in terms of angle between two lines also, where in terms of lines, what are a1, b1, c1, a2, b2, c2, they are the drs of lines itself. But here a1, b1, c1, a2, b2, c2 are drs of normal to the planes. Okay. Plane cannot have plane cannot have drs. So only a line or vector can have drs. Okay. So that difference in notation you have to understand here. Okay. So using this formulas we can find the angle between two planes. Okay. Now we will use some special cases where the planes are parallel or planes are perpendicular and see what is the condition we can write. If planes are parallel, then now planes are parallel means like this. Suppose this is the first plane and this is a second plane. So these planes are parallel. Now when two planes are parallel, what about their normal vectors? This is a normal to first plane n1 bar and this is a normal to second plane n2 bar. Now when two planes are parallel, their normal vectors are also parallel. So this is in this direction, n2 bar is also in the same direction. So when planes are parallel, their normal vectors are also parallel. Now normal vectors are parallel means I can write n1 bar as some lambda times n2 bar. n1 bar can be written as lambda times n2 bar. This is in a vector form. in terms of Cartesian form, n1 bar is parallel to n2 bar means their dr should be proportional. In terms of Cartesian form, dr's are proportional means a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay, we are studying both in vector and Cartesian form. What will be the condition? So this is the condition for parallel planes. Next, if planes are perpendicular, if the planes are perpendicular, suppose this is the first plane and we take second plane like this, pi 1 and pi 2, these are perpendicular. Okay. Now two planes are perpendicular means what about their normals? Normal to first plane we can take like this, n1 bar. Next, normal to second plane we can take like this, n2 bar. So their normal vectors are also perpendicular. Understanding? Two planes are perpendicular, their normal vectors are also perpendicular. Now n1 is perpendicular to n2 means what is the condition we can write? n1 dot n2 is equal to 0. Okay, vectors are perpendicular, their dot product should be 0. This is in vector form. In Cartesian form, what is the condition we can write? n1 is perpendicular to n2, these two vectors are perpendicular means dot product is 0. In Cartesian product, what is the dot product? a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Okay. This is the condition where the planes are perpendicular. Understanding? So angle between two planes in vector and Cartesian form, if the planes are parallel or if the planes are perpendicular, then what are the conditions? Okay. When we are solving the numericals, this will be useful. Okay. Last concept, distance of point from a plane. Distance of a point from a plane. Okay. So derivation not important, only you can remember the formula here. Distance of point from a plane. Now first we study in 2D geometry, distance of point from line we studied. Suppose point is given A x1 y1 and there is a line L with the equation ax plus by plus c is equal to 0. Now what is the distance of point from the line means we have to take the perpendicular distance. So what is the formula for D? Distance of point from the line we are writing D equal to modulus of ax1 plus by1 plus c divided by root of a square plus b square. Remember, in 2D, that is straight lines, we studied distance of point from a line formula. Okay, so similar type of formula we will get here, distance of point from a plane. Okay. So again here also we can write the formula in terms of both vector and Cartesian form. So first we write in vector form. So point is given and plane is given. So let us take the point. Let A x1 y1 z1 be a point and plane equation we are taking r bar dot n cap is equal to d. I will consider plane in a normal form. R bar dot n cap is equal to d be a plane, and let see notation d is already used. So distance I will take capital D. Let d be the distance of point A from the given plane pi. I will take the plane as pi. Okay. So we have to find that distance d of the point from the given plane pi. Okay. Let us see the diagram. So from diagram only we can derive the condition here. Suppose there is a point A here. This is a given point A, and plane pi is given. Suppose this is a given plane pi. This is a plane pi given. Now distance of point A from the plane means what we do is we draw perpendicular from A onto this plane. Okay. Let us draw perpendicular from given point onto this plane. Now this distance, suppose this is m. The distance AM is nothing but required distance d. Now how do we find this distance d here? Plane equation is r bar dot n cap is equal to d. So what r bar dot n cap is equal to d indicates distance. D is the distance of plane from origin because it is in a normal form. So what we do is we know the distance of this plane from origin. So again distance means we have to consider the perpendicular distance. Suppose this is ON. So ON distance we know, that is D. Now here what I do is I will consider a plane passing through point A and parallel to this given plane. Let us consider another plane like this, which is passing through the given point A and it is parallel to this given plane. Okay. So how do we write equation of plane passing through given point and parallel to a given plane? Observe here, this is a given plane. What is n cap or n bar? N bar is a normal vector to the plane, given plane. Now these two are parallel means what about n bar is perpendicular to this plane also. Okay. This is pi given and suppose this is pi 1 I am taking. Okay. So let us take a parallel plane to that given plane. Let pi 1 be a plane which passes through point A, which passes through the point A and parallel to given plane pi. Understand? So this plane pi 1, it is parallel to this plane means normal vector to this given plane is same as normal vector to this required plane. So how can I write equation of pi 1? So here equation of pi 1 is, if you remember we studied plane passing through point and perpendicular to vector n bar. What is the equation of plane passing through point A with position vector A bar, position vector A bar and perpendicular to vector n bar? R bar minus A bar dot n bar is equal to 0. Remember, plane passing through point and perpendicular to vector, equation is r bar minus A bar dot n bar equal to 0. So simplified, r bar dot n bar minus a bar dot n bar equal to 0. R bar dot n bar is equal to a bar dot n bar. This is pi 1. Now I want to find the distance of this pi 1 from origin. So distance of pi 1 from origin means, suppose this is n dash. So what is yn dash? Now yn dash I can find only when yn dash we can find only when if I write this plane in normal form. Pi 1 I am going to write in normal form. R bar dot n bar is equal to something we have. So how do you write in normal form? Divide magnitude of n bar on both sides. R bar dot n bar divided by magnitude of n bar is equal to a bar dot n bar by magnitude of n bar. So distance of plane pi 1 from origin is yn dash. This distance we are finding yn dash. So what is yn dash distance? Compare it with the standard form. R bar dot n cap is equal to d form. So d is a bar dot n bar by magnitude of n bar. So we know yn dash and we know yn. What is yn? Yn is nothing but distance d for this given plane. So this distance am is nothing but distance between n and n dash. From diagram, the required distance d is equal to distance am, which will be same as n dash or n dash n. So how can I write n dash n distance? N dash n distance is nothing but on minus yn dash. It is on minus yn dash. On distance is d. Okay, on distance is d. That is the distance of given plane from origin, because we are taking in a normal form. And what is yn dash? We know a minus a bar dot n bar divided by magnitude of n bar. So this is the required distance. We can write d is equal to d minus a bar dot n bar by magnitude of n bar. Sometimes the difference can be negative, but distance cannot be negative. We have to take a modulus. Understand? So this is how we are finding the distance of point from a given plane. So first what we do, given plane we know the distance from origin. So on we know, that is d. Now what I do is I will consider a plane passing through this given point and parallel to this given plane. Now you write the plane equation. If I write this plane equation in a normal form, that is r bar dot n cap is equal to some distance, then this right hand side indicates distance of this plane from origin. So that is yn dash we are taking. Then required distance is nothing but total distance minus this distance. Okay, so this is a formula in a vector form. Okay, now we will write in Cartesian form. See, Cartesian form is more easier to understand. So whenever they are asking distance, so usually we solve in terms of Cartesian form. Okay. So let a x1 y1 z1 be any point, and plane equation we write in a Cartesian form. Ax plus by plus cz is equal to d. Be a plane. Then distance of point A from plane is given by d is equal to modulus of ax1 plus by1 plus cz1. You bring this constant to left hand side. Okay. So, this plus d will become minus d. If it is minus here, left hand side will become plus. So, ax1 plus by1 plus cz1 minus d divided by root of a square plus b square plus c square. Okay. So, this is the distance of plane from the given point. Okay. So, if you observe, it is in the form ax1 plus by1 plus c by root of a square plus b square, that is distance of point from line in 2D. So, now we are just extending it to 3D. Okay. So, we will get cz1 also, and denominator is c square. Now, this constant, whatever that constant, if it is present in right hand side, we arrange in the left hand side. Okay. So, if it is present in left hand side, no need to rearrange. So, just substitute in place of x, y, z as x1, y1, z1 and bring the constant to left hand side, divide by root of a square plus b square plus a square. This is the distance of point from a plane. Understand? So, these are the concepts related to 3D geometry, it is the planes. Okay. So, with this theory related to planes is completed. So, go through this theory once again, okay, so that we can start the numericals based on this planes in the next class. Okay. Thank you.